kinds of detectors detect in certain vacuum states in certain spacetimes. But the detectors are different and the spacetimes are different, so they're not strictly the same. I mean, all of this is still ongoing stuff. Just earlier this year, as I mentioned, Chris Chalou and I submitted a paper on what Hawking radiation looks like as you fall into a black hole. And the answer is you have to be very, very careful about your detector and how exactly it's moving and how exactly you switch it on and switch it off. You basically don't have enough time when you're crossing the event horizon of the black hole to set your detector to on long enough to detect any appreciable radiation. P. Walder says, do you have a view of whether conscious experience is substrate independent or does biology make a difference? In a recent paper titled The No Body Problem, Anna I don't know who this person's name is, Shiunika, addresses the hard problem of consciousness by suggesting that qualia align with the idea that living systems are fundamentally driven by a homeostatic imperative to maintain their existence. The paper argues that these imperatives are what distinguishes machines based on silicon substrates from agents based on biological substrates. The paper further suggests that the substrate differences may be what accounts for the subjective experience, including qualia of biological systems such as humans from machines. Ultimately, the paper suggests that it is the existential context, as signified by unavoidable death, that creates the necessity of qualia to provide the incentive to maintain homeostasis and thus avoid death. Does this seem like a plausible set of ideas? I'm always very careful trying to comment on papers I haven't seen. I have not seen this one. So it sounds close to things that I would see plausible, but from this particular paraphrasing of it, maybe pushing a little bit too far. It's actually very close to a recent paper by Anil Seth, who was a Mindscape guest not too long ago, on biological naturalism and consciousness and AI. And Anil's paper I actually have read. I'm one of the people who was invited to respond to it in the journal, which is still an ongoing process. But Anil's point was sounds very similar to what you say, Ciaunica, Chonica. Anna Chonica says in her paper. And the way that I would say it in sort of the way that sounds most reasonable to me is the following. It's not an anti-physicalist idea, right? It's still totally physicalist, but Anil is arguing against the idea of substrate independence, much as Chonica is. And Anil's angle on it is that we too often focus on what is called computational functionalism. We think of the brain and the mind as performing a calculation. And as I interpret his point, sure, they do that, but they do other things as well. And you're missing those other things if you just try to mimic a brain or a mind as an AI agent. They're based in biological systems where you get a lot of inputs other than simply, the text that you're reading or listening to in spoken word. And again, there's biological imperatives to stay alive. As Antonio Damasio would have said, there are feelings that you have in order to maintain your homeostasis. There's a lot going on over and above what you are modeling in the form of an LLM or something like that. And I'm actually pretty sympathetic to this. I've said things like this before, that the differences to me between current versions of AI and biological intelligences are much more striking than the similarities, exactly because of this biological embodiment. I don't think I would go so far as to think that these arguments really lead us to a complete rejection of substrate independence. I mean, all the arguments are about functions, right? About trying to maintain your survival, trying to maintain your inner workings and things like that. I don't see any reason in principle why you couldn't mimic these in a different kind of substrate, right? In a mechanical one rather than a biological one. I take the sort of the most persuasive version of the argument to be something like, if you really tried to embody something that was conscious or just even intelligent or sentient, as Jonathan Birch would call it, if you really try to put in all the ingredients over and above the sort of computational power, you would basically end up reinventing biology. I think that's plausible in some sense, and I really don't know the answer one way or the other. But certainly I think it's a very good sort of pushback on the idea that we can just write a computer program and declare it to be conscious. Spock says, are you open to Mindscape guest suggestions from listeners? What catches your eye? I'm curious if I was close with one who brings his own martini and sparks unique insights. Yeah, no, I'm 100% in favor of suggestions of guests to Mindscape from listeners. Several, I don't even know what the list would be, but certainly several actual guests have been because a listener suggested them, and I looked them up and said yes. There's an enormous number of factors that go into me picking guests. There's lots of guests out there, and many good ones who I'm sure I've never even heard of before. So that's why I like to get suggestions. I get a lot of suggestions already. So if you make a suggestion and I don't follow up on it, there is a limit on how many I possibly can. So don't feel bad. But look, I'm looking mostly for people who have ideas, and especially people who have actually, created something with their ideas. Like if someone is just generally smart, able to comment on anything, things like that, that's actually kind of a turnoff to me if that's their claim to fame. I want to know what they've done. Have they written a book? Have they pioneered a field? Did they make a discovery or something like that? The substance of it is much more what I want to talk about. I like talking to academics, but certainly I'm not limited to that. Something like the martini thing, I just had a podcast about cocktail theory, and the thing is, as soon as I have a podcast, I always get a bunch of suggestions of somewhat similar podcasts, not exactly similar, but, along the same theme. But you should know that's exactly what I don't do. If I've just had a podcast, I'm probably not going to do a similar topic for a while, usually, especially if it's a quirky, fun topic like cocktails or whatever. Potential guests have to be people who are good at being a podcast guest, ideally, right? Which means that, they know their stuff, but also they're good at explaining it. I can get them for an hour and a half to talk and things like that. So there are many things that go into it, but sure, absolutely send your suggestions along through comments on Patreon, through comments on preposterousuniverse.com or whatever. Moritz says, priority question. Does the fact that information needs to be physically instantiated in finite space pose a problem for determinism? E.g., could the Big Bang really contain all the information needed to determine the entire future of the universe? What's your stance on determinism and free will? So that's more than one question. You're not allowed to ask more than one question, even for a priority question. But I think there's a theme to the question that I will try to get into. I don't even know what it means to say the fact that information needs to be physically instantiated in finite space. I don't know why that is true, why I should believe that, whether it's true. I don't believe space is fundamental, so I'm not even sure I know what that means to say something like that. Could the Big Bang really contain all the information needed to determine the entire future of the universe? Yes. Why not? I mean, remember, the Big Bang in the classical theory of general relativity is a singularity that is just not describable at all. A moment after the Big Bang, the universe could have been infinitely big. So there's no limit. There's no obvious boundary on how much information you can have in the Big Bang. It seems like there's plenty. As far as determinism and free will is concerned, plenty of places to look up on the internet what my opinion about that is. I've written about it many times. It is that I'm a compatibilist about the two ideas. Eric Dovigi says, under what circumstances, if any, do you believe that violence is justified in combating institutional evil? Quick example, if a gas company were about to drill in a pristine natural area and the project was certain to destroy a great deal of wildlife, what criteria would the situation have to meet for me to be justified in blowing up the gas company's infrastructure? I think that there is, on the one hand, there's no absolute prohibition against doing things like that, but I think that the preponderance of feeling should be that that's usually almost always a bad idea. Violence to achieve political ends is exactly the kind of thing that can be kind of romantic and attractive to the right kind of person under the right kind of circumstances, but that doesn't mean it's effective. And what you have to do is think about, number one, are you 100% sure, or at least as metaphysically close to that as you can get, that you have correctly judged the moral calculus here before you start blowing up some infrastructure and potentially injuring people? Are you absolutely convinced of the correctness of both the physical facts on the ground and of your personal ethical weighing of what would be good and bad? But then, much more importantly, and also much more difficultly, what will be the consequences of your action? Is the gas company going to stop being a gas company because you've blown up some of its infrastructure, or will they just raise prices on gas? Will you very dangerously set a precedent for increased violence and the justification of violence by people who maybe are not as morally correct as you? Remember way back when, very early in the podcast, I did this interview with Ed Watts, who is a historian of ancient Rome. And it's one of those podcasts that has absolutely stuck with me years later, and he talks about the decline in the Roman Republic and puts a lot of blame on the Gracchi brothers, these two aristocrats in ancient Rome who had the idea of assembling a mob to basically intimidate the Senate into doing what they wanted. And they didn't really get what they want, but more importantly, they set the precedent that when we don't get what we want, we assemble a mob. And that's a precedent that anyone can use, not just you. So when you start blowing things up to achieve some political aim, you have to realize, okay, now the thing to do to achieve a political aim is to blow things up. Right? And maybe the people who you don't agree with are going to agree with that strategy and start using it themselves. Again, I think there's just a huge bias or inclination that it's the last thing you should do. It can potentially be justified, but it's probably not as justified as you initially think. David Maxwell says, I just watched the NATO Secretary General publicly flatter the President of the United States like a scene from The Godfather. Of all the things to worry about right now, how much should we worry that world leaders must debase themselves to avoid U.S. enmity? Is it harmless diplomatic speak or something far more insidious? I think that of all the things to worry about right now, that's a very, very tiny one. I mean, it makes the United States look foolish that we have leaders who are susceptible to this. It makes the other leaders look foolish because they're doing it. But the looking foolishness is really just not something that is high on my list of worries, just because there's so many other more tangible things going on. Yazan al-Hajari says, people often say there's a touch of madness in every great mind. How do you balance that intense logical side of your work with your emotions and that little bit of creative madness? Do you have any outlets that let that side of you shine? Well, I don't quite agree that there's a touch of madness in every great mind. Either that or maybe my mind is not all that great. I think that among physicists who I know very well, some of them you could absolutely kind of perceive a touch of madness. Others are kind of, they're kind of logical and straightforward and, matter of fact about the work they do. I think that I'm, relatively under control when it comes to those things. I can occasionally be creative, but I don't think it necessarily leads to anything or is involved with anything that anyone would recognize as madness. Maybe that's just what a mad person would say, but that's my self diagnosis anyway. Henry Jacobs says, I'm troubled by canonical quantization. It's good to have people listening to Mindscape who are troubled by things like canonical quantization. I think that's just charming. It appears, Henry continues, that the process is, number one, write down a classical Hamiltonian as a real valued function of canonical coordinates. Number two, close your eyes and pretend that each of the Q's and P's are not coordinate functions, but are actually operators on Hilbert space, satisfying some specific commutation relationship. Now you have a quantum Hamiltonian. And step 3, forget that step 1 ever occurred so that the only memory you have is of the operator obtained in step 2. Perhaps this can be done with a good knock to the head. Seriously, this is the way? That's Henry's question. Apologies that this is a little technical for many of the people listening, but I'll try to be quick. And it's a really good question. It's a point that I often make. Yes, Henry, that is the way. That is what people do. But the justification for it at the end of the day is ultimately pragmatic, okay? There's two things you need to keep in mind. Number one, there is not an algorithm, a map, a well-defined procedure for taking a classical theory and making the one true quantum theory out of it, okay? There's just not a unique map from classical theories to quantum theories. For any classical theory, there are generally multiple quantum theories that kind of resemble it. For some quantum theories, there are no classical theories that it comes from. And for some other quantum theories, there are multiple classical theories that it comes from. So there's just not a good relationship between classical mechanics and quantum mechanics. And that is fine. There's no reason why there should be. What there is, when you are lucky, is a classical limit of your quantum theory. So you start with a quantum theory, and in certain circumstances, you can show that you get classical behavior out of it. In others, you can't. If you have a single qubit, there is no classical limit to that. But when you have a big macroscopic collection of stuff, there might be. But that's okay if what you keep in mind is ultimately I just want to find a quantum theory and test it against experiment. This procedure that you outlined is not supposed to be some airtight procedure for finding the correct quantum theory. It's just a way of getting a quantum theory, and then you have to ask yourself if it works, okay? If there's another way of getting the quantum theory, then use that. The nice thing about canonical quantization is that if you do all of this magic that you just talked about, then usually in well-behaved circumstances, the classical limit of that quantum theory that you get will be either exactly or very close to the classical theory that you started with. I don't know a theorem that says when exactly that happens and when it doesn't, but something like that is often the case as a matter of fact. So it is sort of not quite legitimate from a purely logical point of view, but it works in practice, and to physicists, that's usually what they care about. George says, I teach high schoolers physics and math, and I'm often met with why questions about the fundamental nature of the world. Why is the mass of an electron what it is and not something else, for example? I don't fall into the camp that physics only answers how and not why questions. However, when the why questions apply to something sufficiently fundamental or seemingly axiomatic about our universe, I really struggle to come up with an answer that satisfies the itch that accompanies such a question. How would you respond to these questions in a way that a student might walk away satisfied with the answer? Well, first I would say insisting or even aspiring that the student walks away satisfied is too high of a standard. You can never guarantee that students are going to be satisfied, even if you give people an entirely correct answer, because what counts as satisfying to them might be impossible for you to quite reach, or might not be true. Maybe the world is not satisfying to them. When people ask about why questions in physics, I think you are completely correct that it is wrong to think that physics only answers how questions and not why questions. That's one of these simple bumper sticker mottos that does not hold up to any scrutiny at all. Physics is answering why questions all the time. But at the same time, it doesn't guarantee you an answer to every why question. There can be in the world brute facts. There almost need to be. If you imagine there could be different possible worlds, and there's a question of why do we live in this world rather than another one, that's a brute fact right there. The weird thing is that when it comes to fundamental physics, we often don't know whether a specific question is answerable, a specific why question, whether a specific feature of the world has a reason why or is just a brute fact, okay? The mass of the electron is exactly in that category. It is, on the one hand, perfectly respectable and frequently done to try to create theories that predict the mass of the electron. Not exactly the mass of the electron, because that's a dimensional number, but something like the ratio of the muon mass to the electron mass, okay? You can try. You can absolutely do it, and maybe you succeed, and then you've done it. You've explained why. But you can't demand ahead of time that there is an answer. You have to say, well, we're going to try. If we win, that's great. If we don't, we accept it. Ultimately, what nature is the final answer, not what we want nature to be. Folkman says, I was thinking about the inevitability of the development of highly intelligent life forms on Earth and in the universe. Under what evolutionary conditions will it develop? Dinosaurs reigned supreme on Earth for almost 200 million years, and as far as I know, never developed advanced intelligence as we understand it. Had it not been for the asteroid that led to their demise, they might still be ruling Earth, and mammals, ultimately primates Homo sapiens, might not have had the chance to flourish and develop intelligence. Intelligent life on Earth almost seems like a fluke. What do you think this means for the chances of intelligent life developing elsewhere in the universe? I think what it means is that we have no idea what the chances are of intelligent life developing elsewhere in the universe. On the one hand, you're right. We know it's possible for life to exist even in highly complex forms here on Earth for hundreds of millions of years in a row without getting all that intelligence, because it happened. You can't deny that it happened. And then there was a an event that was kind of unpredictable. And this often happens in evolutionary biology in particular, in complex systems more generally, that when you put some external, you subject the system to some external jolt that changes things dramatically, it might suffer some temporary decrease in viability, but it also starts examining and exploring new parts of configuration space and parameter space, which turn out to ultimately be actually more robust and favorable and fit than the ones that it was already trying. So it goes perfectly naturally with the metaphor of a fitness landscape. I talk about this in the big picture. And the fitness landscape idea, which has its limitations, it's not perfect, but it's pretty good for sort of getting some intuition. You imagine a rugged landscape as a function of what genome you have, okay? The problem is genomes are very big, and we can only imagine sort of two-dimensional landscapes, so that's already a problem. But let's imagine we can do it, and imagine that high peaks on the landscape have a lot of fitness and reproducibility and things like that, so populations of species naturally sort of move up via natural selection to the peaks of the landscape. Now, maybe there's a peak far away that is even higher, that would be even more fit, but in between you and there is some valley, right? The dynamics of natural selection give you no way to cross that valley because you just go by random motions, and most of your random motions are pretty small. So they will, if you're already on one peak, generally take you to places of even lower fitness. That's why the jolt from the asteroid is so important here. Now, what does this mean for the development of intelligence? I think that it seems to me very likely that under a wide variety of circumstances, developing intelligence is useful to biological fitness. On the other hand, it may be that there's a wide variety of circumstances where you don't have any intelligent beings in the ecosystem, and you're more or less stable in whatever configuration you're in, and you see no reason to undergo the dramatic changes that evolution would require before developing intelligence. Or maybe not. I mean, arguably, as we talked with Peter Godfrey Smith, arguably octopuses are intelligent in a sense, and maybe if you gave them enough time, they would build spaceships. I really don't know. Maybe they can't build spaceships no matter how intelligent they get because of the differences in living in water versus living in air. So I'm trying to be very humble about these things. People make these definitive sounding statements, but I think that there's a lot we don't know about exactly what went into the ability of human beings, not just to be intelligent, but to technologically influence the world around them, to really shape it and control it in ways that require not only intelligence, but a lot of other factors as well. Who knows how many contingent lucky events were part of that? You know, my evil twin, Sean B. Carroll, wrote a whole book emphasizing exactly that. And we had a podcast conversation about it, the important role of contingency and randomness in the development of life on Earth. So I think it's perfectly legitimate to simultaneously hold two ideas, that intelligence is generally adaptive and a good thing for evolution to find, and at the same time, there might be a tiny probability that it actually is found out there in the space of possibilities. I don't know. The probability might be large, might be small. I'm pretty open about that. Jeff Stone says, aside from my day job somewhere out there in the sciences, I am 62 years young, very health and diet conscious, semi-serious amateur athlete and international mountain sports adventurer. Over the past 6 weeks, my assumption of immortality has been challenged by a diagnosis of an advanced and serious form of cardiovascular disease, followed by cardiac catheterization and stenting. Now, rather than training and adventuring, I'm spending 3 sessions per week in a cardiac rehab program, exercising at walking speed indoors while EKG telemetry is continuously monitored in real time to keep me safe. My biggest issue is anxiety. By that I mean overwhelming panic attack, emergency department visit level anxiety. I'm receiving professional help of every kind. I'm happy to report that the Mindscape podcast, your audiobooks, and your sonorous voice are a welcome break from my own chaotic stream of consciousness. You already serve as a gentle supplement to other forms of mindfulness and contemplative practice. Do you have other specific words of wisdom for me? I'll just close my eyes and listen. Jeff, thanks for writing this, and I'm sorry to hear about these kinds of problems from someone who is of a similar age cohort as you. I have not faced that exact situation yet, but we're eventually all going to come to it, right? I think that I've said this before, that it's one of the great failures of our society, how we're bad at thinking about the fact that our lives are always finite, right? I don't want to say even thinking about death, because that's a little bit too dramatic, but we do tend to think that we want to live forever, and in fact, it's not going to happen, right? We kind of know intellectually it's not going to happen, but we ignore that fact. I did have, as early as episode 10 of Mindscape, I talked to Megan Rosenblum about the death positive movement, a movement of people to try to sort of recognize the reality of death, the necessity of it, and accept it. And, not necessarily to think it's good, but to think that it's something that we need to accept, therefore we should learn to do it. And I don't even know, for Jeff's question, I mean, it's not necessarily a question of mortality and, our facing limited time horizons, but also one declines in health and in ability as one grows older. You don't bounce back as much as you used to. Those are all things that we have to deal with. But I do think that the finitude of our lives is the big thing, right? Is the thing that leads to these moments of anxiety and inability to sort of know what to do, because you're powerless, right? You are by definition powerless. You can maybe do the right exercises, do the right health routines, and survive for longer rather than shorter, but it's all going to come to us. The end will come to all of us. I think on the one hand, it's entirely legit to feel anxious in the face of that sort of powerlessness. It's not a mistake to feel anxious about it. It would be a mistake to let that anxiousness overwhelm you and prevent you from living the life that you have. I don't like giving out words of wisdom. I can suggest things to think about. I think that just thinking about it, I just think facing up to it and really thinking about what it would mean is already the single biggest step that you could take, which you're already obviously doing. It's very, very difficult to conceptualize death because by construction, there's nothing it is like to be dead. Thomas Nagel might think there's something it's like to be a bat, which is different than what it's like to be a human. There isn't anything that it is like to be dead. There's no point of view. There's no perspective. We're not dead and looking back and going, oh, well, I regret doing that. There is only what we are thinking while we're here and we're alive. And, very few of us really think, some will eventually come to the point, but most of us do not think, yeah, I've done it all, I'm done, right? Like there's more that you want to do. There's more fun you want to have, more people you want to talk to, more things you want to learn, whatever it is. So it's entirely okay while you're alive to feel like, at the very least, annoyed, irked by the fact that you can't, in fact, be immortal and live forever. I do think that once you accept or come as close to accepting as possible the inevitability of your eventually not being here, that helps make your mental attitude toward that reality a little bit healthier in some very real sense. You can think about, okay, have I been doing in my life the things that I maybe not everything I wanted to do, but the kinds of things that near the end would make me relatively satisfied with the life I've led. Of course, we all have ups and downs. No one is going to make all the right choices all the time, but we can come closer or less close depending on the choices that we actually make. And, are there still yet good things that I can do for myself or for other people to try to sort of Think about the people who you know who are no longer with us. Mindscape's been going around long enough now that several former Mindscape guests have died since we started it. And I think of them very, very fondly, right? And, I would like to be thought of fondly after I'm gone, but I don't care that much because I'm going to be gone. But you can think while you're alive about whether or not the life you've been leading is one that other people will think fondly about, I'm always, in the face of things you can't change, I'm always interested in thinking about the things that you do have some influence over or control over. You don't have any influence on whether or not you will live forever. That is not something that you can control. What you can control, or at least influence in some way, is what you do with the life you have, both, at the moment and in whatever future moments we each have. Is that helpful or useful information? I have no idea. I suspect it's very, very personal. I suspect that different people are going to react differently and think differently and have different useful strategies for coping with the inevitability of the end of our lives. I'm just going to repeat myself. It's not easy. It's not supposed to be easy. There's no simple answer. We're all going to deal with it in our own way. And it sounds like you're dealing with it in an extremely mature and good way. So congratulations to you. I hope that you get to keep treating it that way for several decades to come. Rod Edkerson says, does the rise of masked ICE terrorizing Americans and our guests concern you? Does the multiple murders, arrests, and censuring of elected Democrats concern you? Yeah. Obviously, it concerns me enormously. What can I say? I think that we are it's impossible to be too alarmist right now, basically. If you said 10 years ago, like, here is a bunch of things that if they happened, I think it would be a warning sign that our democracy is eroding and we're descending into totalitarianism. Many of them have happened. Just indisputably, the huge budget that was just passed for ICE, for non-Americans, that's what does ICE stand for? Immigration something enforcement. Who cares what it stands for? The ICE people are like a paramilitary police force with very little structure or control or limitation that is part of the federal government. And they've been, for those of you who are outside the country, maybe not following the news, without any coordination with law enforcement or whatever. These people dress up in sort of ridiculous outfits, wearing masks, no badges, no identification. Often they put on camouflage, even if they're in the middle of a suburban shopping mall, and you're thinking, what in the world are these people thinking? They're dressing like they're in Fallujah and they're in Des Moines and carrying high-powered weaponry, and they pick up people and put them in vans and take them away. How can you not be scared by that? As Rob says, Democratic politicians, and they don't even need to be Democrats. I'm sure that the administration would be happy to arrest any politicians they didn't like. They're not randomly arresting politicians, but there are politicians who are trying to do their jobs by, for example, investigating detention centers, and they're being arrested for doing it by this weird paramilitary organization. It's very, very bad. What can I tell you? I think that we're basically building concentration camps in Florida right now. We're bragging about how many people can be sent there. We're inventing new rules where you can be an American citizen, but they can take that away from you by various strategies, and there's no recourse to due process. They make fun of the idea of due process. They say if you had due process, we couldn't arrest and deport all these people nearly as easily as we were doing. It's terrible. It's going to be historically a black mark on the United States of America for centuries to come, whether or not the United States survives as a democracy. So yes, I am concerned. I'm not quite sure what to do about it. What little I can do, I'm doing. Claim says, how can we still see the cosmic microwave background nowadays? Why aren't all the photons already absorbed or moving away from us like everything else? Well, moving away from us like everything else. It depends what direction you're pointing in, right? The photons are redshifted since they were last scattered, I guess is the right way to say it. But remember, or let me tell you, the cosmic microwave background comes to be at a moment called recombination, which is not quite a moment. It's an era. It's a sort of smooth, gradual process around 380,000 years after the Big Bang, when the universe becomes transparent because electrons and protons finally hook up to make hydrogen atoms. And it's not a place, the cosmic microwave background. It's a time. It's created at a time. It's created everywhere in the universe. So starting from now, I can just ask the question, if I trace backward in time along a light ray, will I eventually hit that moment of time? Yes, yes, I will. And that's where the cosmic microwave background photons come from. Now, why aren't they all absorbed? Because space is mostly empty and transparent, right? That's why if you look into the sky, it looks black rather than glowing bright. If we lived in a cloud of interstellar gas and dust that was opaque, then indeed all the photons would already be absorbed. But most of outer space is not like that. It's not perfectly transparent, but it's pretty darn transparent. Ted Anderson says, did Robert Frost suggest an answer to Princess Elizabeth? Princess Elizabeth challenged Descartes to provide a mechanism for downward causation. Parenthetically, this is Sean talking now, this is an incident that is talked about in my book, The Big Picture. So Tad goes on to say, Robert Frost's poem, The Road Not Taken, seems to me to suggest an answer. 2 roads diverged in a yellow wood, and sorry I could not travel both, and be one traveler, long I stood. A thinking being encounters this situation all the time. This is Tad again, not Robert Frost. A decision must be made, left or right. And Tad, you've added a lot of words to your question, so I'm editing you. Word to every future question asker. If you don't want me to edit the question, keep it short in the first place. In the moment of the poem, the microstate is set, but both choices still seem to be possible. Indeed, both choices are possible in that moment if we simply posit that more than one macrostate can be compatible with a single microstate. How do you know that a given microstate can never be compatible with 2 different macrostates? Is this a requirement of physicalism, or is it separate additional proposition? Can it be tested even in principle? So I think that you have this a little bit backwards when you say, in the moment of the poem, the microstate is set, but both choices seem possible. The reason why both choices seem possible is because the microstate might be set, but it is not known. And it is certainly not fixed by the macrostate. What you know is the macrostate. You know, here's a person, they're facing a fork in the road, etc., 2 paths diverging in a yellow wood. And what are they going to do? Okay. It might very well be the case that there's a specific microstate of the person facing this choice, which if you knew it and you had perfect calculational ability and knowledge of the laws of physics, you could say exactly what that person was going to do. They would go either left or right. Okay. So both choices would not be possible given all of that knowledge. But the reality, and this is the reality not just for Robert Frost, but for all of us, is that we don't have that microscopic knowledge. The idea that we are making choices and that there are many things that are possible in the future is because of our incomplete knowledge. So the issue is not that the microstate is set and it is compatible with multiple macrostates. That is just not how emergence works in the examples that we know and understand. It's that we know the macrostate before the decision is made, and is compatible with many, many different microstates, some of which correspond to going left, some of which correspond to going right. Sean B. says, I am not a fan of the simulation hypothesis, but I often wonder about the mathematical structure of the universe. If we can model the origin mathematically and deterministically, doesn't that suggest we might be mathematical objects embedded within a larger mathematical framework? No, it does not suggest that. I don't know why it would suggest that. If you thought it suggested that, what about the people doing the simulating? Are they modeling their universe mathematically and deterministically, and are they therefore likely to be in a simulation themselves? I don't think that there's any connection between the success of mathematics in describing the universe and the possibility we live in a simulation in either direction. So I don't think that if there were, let's put it this way, if I did a simulation I could easily inject into the simulation all sorts of violations of mathematical regularities and so forth. So that's completely compatible with living in a simulation. And the other way, the fact that there are mathematical regularities, I don't see a need to explain that by referring to a bigger simulation. Mathematical regularities are perfectly expectable, I think. This is a question we don't know the answer to. This is one of those questions we just talked about before. Is there a reason why our universe obeys laws of physics? I don't know. Maybe it just does, but I don't feel the need to explain that by referring to a higher level who is simulating me. Victoria Lucas says, I'm a medico-legal death investigator from Texas and an atheist, but some of my experiences have troubled me over the years. What are your thoughts on deathbed visitations? These are not near-death experiences, but deathbed visitations on people that are in the process of dying. Why do you think dying people hallucinate dead relatives or friends and not living ones? Well, I think dead people hallucinate all sorts of things because they're dying, because their bodies and minds are failing. This is no more weird to me than why I have weird dreams at night. Like when I'm dreaming, my body and brain are perfectly healthy. I had very weird dreams last night where Jennifer and I were living together in Chicago, which we never have actually done, but I used to live in Chicago, and we were searching for an amplifier. I really don't know why we were searching for an amplifier. It makes no sense, but that's okay. It's not supposed to make sense because it's kind of random little associations bouncing back and forth in my brain. When you're close to dying, why do you remember people who you haven't seen for a long time? Again, this just seems like not at all implausible to me, especially when the alternative is supposed to be completely violating the laws of physics in order to make these former known people actually real somehow. Peter Schuller says, how do you reach out to potential guests of the podcast when they don't know you? If you send an email, what do you say? Is there any tension between getting someone's attention, proving your email is worth reading and or taking seriously, and coming across as self-aggrandizing? Yeah, that's a good question. You know, as someone who receives a lot of emails myself, I like it when the emails are short. So I don't like it when someone sends me an email and I have to read to paragraph 3 to find out what it is they're saying. So I do send out emails myself, and they're generally very short, and they start with, I'm writing to ask whether or not you'd like to be a guest on my podcast, Mindscape, and then I give a link to the podcast. And then maybe another couple sentences about what the podcast is about, what we could talk about, things like that. And that's it. Sometimes it works, sometimes it doesn't. I have no problem at all with people who don't want to be on the podcast. That's fine. I say no to a lot of other podcasts. So I don't generally hector people. Like sometimes people will write back and say, oh yes, sure, that sounds good, let's do it. And then I'll write back to them and say, okay, let's pick a date, and I never hear from them again. Those people I will hector a little bit. And again, it's probably not their fault. I get it. I've been there too. Sometimes you just don't get around to answering the emails. But I'm not going to, try to prove to someone that they really should be on my podcast. That's a choice that they're welcome to make or not. Joe Siebert says, I think I subscribe to the notion that you can't derive an ought from an is, but then I wonder, where do oughts come from in the first place? Is there any kind of study of the nature of oughts that might point us towards some actual universals or near universals about morality? Well, yeah, I mean, there's plenty of people who think that they have a way of getting universals or objectively true facts about morality. Russ Schaefer-Landau, who was a previous guest, is a leader of such people, but they don't have a unified front. There are plenty of different approaches to doing that. My answer is that there aren't any actual universals or near universals about morality. So the question, where do oughts come from, is from us, from individual people and collections of people trying their best to figure out how to reconcile their moral intuitions with how they think systematically about what is right and wrong. And we call that endeavor moral philosophy. And it might never be objective. It might never be realist in the sense that the physical world is real, but that doesn't make it any more useful for that. Blake McEwen says, when my cat needs something and she gives me that look, I go and do the thing she needs, and she responds as if we communicate. I believe she is conscious, and I suspect you feel the same way for Ariel and Caliban. Where do you think the rock bottom is for consciousness? Clearly not a rock, but maybe bacteria. Well, my own view, which is not anything close to educated or set in stone or unwilling to be changed by further data or even persuasive argument, is that it's a continuum. I don't think that there is necessarily some phase transition where you go, oops, before you were not conscious, now you are. There might be a series of small phase transitions that give you different capacities that are part of being conscious. Maybe even microorganisms can have a certain amount of information processing or self-awareness. Later down the evolutionary ladder, you have the ability to plan and imagine, as Malcolm MacIver talks about. There's a whole bunch of things that go into being conscious. So I don't think that there is any such thing as where the rock bottom is. That might sound like I'm cheating out of the question, but those are my honest feelings. Zach McKinney says, what is your level of credence that consciousness is a substrate-dependent phenomenon? You often describe consciousness as an emergent property of information processing physical systems. However, when speaking with Christoph Koch, you took issue with his hypothesis that consciousness might arise from a state of quantum superposition on the grounds that superposition is not an objective fact about a system, but rather depends on the choice of informational basis to describe the system. Does it follow that you believe consciousness must be substrate-dependent because the presence or absence of consciousness in a physical system is an ontological question, whereas any definition of consciousness in terms of pure information processing will necessarily fall subject to the arbitrary choice of what properties of the system to count as information? Well, no, that's not quite the argument I would give. I think that the quantum mechanics thing is a separate thing. Quantum mechanics is kind of special in this fact of superpositions and the fact that superpositions are not objectively defined, but rather relative to a basis. There's a lot, I'm not quite sure exactly how to describe, how to respond to the various points in the question here. Is consciousness ontological? Consciousness is a property that physical systems can have, and whether or not we choose to ascribe consciousness to them depends on the usefulness of that. I mean, this is the pragmatist in my philosophy coming out. What good is it to describe something as conscious or not? Does saying that tell you something useful? Can you do something that is predictably correlated with what is happening in the world on the basis of that piece of information? So I'm agreeing, I guess I would agree that I've been persuaded by the arguments we talked about earlier in the AMA from Anil Seth and others that there is more to consciousness than information processing. But I don't think that that takes it as far as saying it's completely substrate dependent. Maybe it is easier to imagine it happening in certain kinds of substrates, biological, for example. But if it's not pure information processing, then I still don't see any obstacle to reproducing whatever are the features of consciousness in all sorts of different substrates. At the very least, I could imagine building larger objects, macroscopically big objects, that sort of interact with each other like atoms interact with each other, and therefore build a huge brain-like thing that was more or less conscious. It might take decades, eons, or whatever to have a thought, but I don't see the obstacle to that as a thought experiment. So I'm not willing to go so far as to say that consciousness is inextricably dependent on a substrate, but it might be as a matter of practice that biological substrates are just much more likely to get there. Brent Meeker says, why isn't there more interest in CP or T violation? Time reversibility is often invoked in physics thought experiments and Boltzmann brain puzzles, but CP violation says it is not time reversal invariant. It turns out, as you can read in various places that I've written, like From Eternity to Here, or one of the biggest ideas in the universe books, I forget which one it was, but it is time reversal invariant. It's just an accident of history that what we call T, the time reversal operator, is not the right one. What we should have called T is what we do call CPT. So for those of you who have no idea what I'm babbling about, in particle physics there are three famous discrete symmetries. In fact, they are two-way symmetries, parity kinds of symmetries, that if you do the symmetry transformation twice, you come back to where you started. One is literally P, parity. You change right-handed coordinate systems for left-handed coordinate systems, or basically you look at the system in a mirror that switches right and left. Another is C, which roughly speaking switches particles and antiparticles. And another is T, which is time reversal invariance. You might think that knowing what time reversal invariance is a completely obvious thing to do. There's not a lot of choices that go into it, but you would be wrong. The correct statement is that there is always, in every deterministic set of dynamical laws, a transformation you can do that reverses the direction of time and is a symmetry of the system. The real important thing is information conservation and reversibility. When you have information conservation and reversibility, you will always have some time reversal symmetry. So for example, in electromagnetism, it turns out that if you do time reversal, the electric field is unchanged, but let's put it this way, I can make up whatever transformation I want. And then I can ask, is it a symmetry? So if I do a symmetry where I just change t to minus t, time to minus time, that would not be a symmetry of electromagnetism, classical Maxwell's electromagnetism. What I need to do is take the magnetic field and also reverse it, but not the electric field, okay? So E goes to E, B goes to minus B, and T goes to minus T. That is a good time reversal symmetry. Indeed, in Hamiltonian mechanics, where you have positions and momenta, the thing about Hamiltonian mechanics, which I do beat on about in the first volume of The Biggest Ideas, Space, Time, and Motion, is that you truly treat position and momentum as two independent variables. You do not define momentum to be the mass times velocity. You derive that that's a fact, but in principle, those two things are separate. And the right time reversal invariance operator sends x to x and p to minus p, as well as t to minus t. It reverses momentum and time. So basically, you have to think about what would make a good time reversal operation. In the case of quantum field theory, the good time reversal operation that is a symmetry is called CPT. You change t to minus t, but then you also change the parity of the system and you charge conjugate it. You change particles to antiparticles. D. Dashevsky says, it seems like the number of mechanisms for faster-than-light travel, such as stabilized reversible wormholes or Alcubierre warp drives, require negative mass exotic matter. Is there anything to this similarity, or is it mere coincidence? Also, is there any reason to interpret those results as anything more than a fancy way of saying, this could work if it was possible, but it's not, so it won't? For the latter question, I think that's more or less the way I think about it. This could work if it was possible, but it's not, so it won't. You know, we don't have any theorems to that extent, as far as I know. At least we don't have any theorems that we completely believe, in part because we don't have a full theory of quantum gravity, right? So we're trying to work with classical gravity and some approximations about quantum mechanics and matter fields and stuff like that. So it's hard to know these things for sure. And there's another problem, which is very much a problem of principle. For those of you who don't know, the Alcubierre warp drive was an idea. Miguel Alcubierre, a Mexican physicist, wrote down a metric on space-time. I don't even want to say a solution to Einstein's equation, because every metric is a solution to Einstein's equation for some kind of matter fields, right? The matter fields might not be realistic, but I can write them down. What does it mean for matter fields to not be realistic? Usually it involves negative energies or negative masses. If such fields existed and were sort of macroscopic and big and manipulatable, they would probably mean that space-time itself was just dramatically unstable, because you could make a big blob of negative energy and a big blob of positive energy while conserving energy overall. And by quantum mechanics, that would happen all the time, and it clearly doesn't. So in realistic circumstances, you probably don't get appreciable amounts of negative energies, and things like the Alcubierre solution require some negative energies. So anyway, what Alcubierre did was he wrote down a metric that looks like the following thing. If you just imagine flat space-time, so you imagine Minkowski space, and I have this thing called where I am now on Earth, and then Alpha Centauri is 4 light years away, and you would think that it takes me 4 years worth of travel to get to Alpha Centauri. That's hard to quantify because you're in a certain reference frame, right? And in a different reference frame, it's different, but there's a number, which is how long it takes to go to Alpha Centauri and back. And that's at least 8 years, right? That's the speed of light limit, and that's very well defined. So Alcubierre came up with a distortion of Minkowski space that was basically in the form of a bubble, okay? And this bubble looks like it zooms out to Alpha Centauri and it zooms back. And you could imagine putting a spaceship in this bubble, and the zooming out goes much faster than the speed of light. But to be super duper careful about that, it looks like it goes faster than light would have gone in the original Minkowski space. The point is, you have changed the metric on space-time so that nothing actually goes faster than the speed of light. It's only a comparison between what actually happens and what would have happened in a completely different universe. So does that count as going faster than the speed of light? Well, for all intents and purposes, you can, if you could build this so-called warp drive, you could look like you were going faster than the speed of light. It raises huge problems with the initial value problem of general relativity. That is to say, given the initial data, how do I evolve it forward in time? Things like that. People debate about whether or not this is possible even in our imaginations, much less in reality. I personally suspect things would go very, very wrong if you tried to do it. So all of which is to say, the short version of this answer is, I am sympathetic to the idea that there is something physically completely infeasible about all of these suggestions about faster than light travel in practice. But because we don't know exactly how to define the problem, and certainly we don't know quantum gravity perfectly well, it's hard to know for sure right now. Callan McAuliffe asks a priority question. The Goldilocks fog conjecture posits that when the density of an evolving system's decision space exceeds its neurocomputational resolution, the inability to individuate its many choices is perceived as an illusory, edgeless sense of self, just as droplets form a fog. In other words, I reckon phenomenal consciousness emerges within an evolutionary window of cognitive blurring, outside of which the decision space is too easily parsed, either because it is very simple, too few droplets to form the fog, or because the modeling resolution is sufficiently advanced, capable of resolving the droplets in the fog. One implication of this is that a superbrain might be as conscious as a bug, another is that I'm out of my depth. If I could, I'd frame this as a compliment to AST's modeling and perhaps GWT's architecture, but that's well beyond where my amateur insights runs out of road. Is there any merit to this idea? So the idea here, if I can sort of try to paraphrase it, is conscious beings, have a certain way of